In section 11.7, we're moving on to finding the volumes of pyramids and cones. So here's the theorems. Theorem 11.9 is the volume of a pyramid. The volume V of a pyramid is V equals 1/3 the area of the base times the height. So it's just like when we were doing prisms. You find the area of the base, multiply by the height, and instead of multiplying by 1/3, I would just do the B times H and then divide by 3. For the theorem 1110 is the volume of a cone. The volume V of a cone is equal to the volume equals 1/3 the area of the base times the height, just like before. So again, if you find the area of the base times the height, just divide that by 3. But remember, for a cone, your base is always going to be a circle. So it'll end up being like pi r squared for the area of your base times the height, and then divide by 3. So just like we did yesterday, what I want you to write down for the volume of pyramids and cones is this. V equals 1/3 big B times H, and then write down volume is the area of the base times the height, and then divide by 3. Let's look at our first example. So here's number 1. Find the volume of each solid. So for part A, we see that is a pyramid. So again, we're going to start off with the volume is equal to 1/3 the area of the base times the height. In this case, the base is a square because we see that each of the 4 sides are marked as congruent. So the base would be found by doing length times width, or side times side. So 14 times 14, which is equal to 196. The height is 10, and the one thing I want to point out here is the height always has to be the perpendicular distance from the tip of the pyramid straight down to the base. Same thing goes for a cone. So again, the height is 10, so we're going to do volume is equal to, again, we're going to do the 1/3 last by dividing by 3. So 1/3 times 196 times the height of 10. So I'm going to take the 196 times 10, take that answer, and divide by 3 to get about 653.3. And since we were given the label meters, it'd be cubic meters as my answer. Let's move on to part B. We have a cone, and this would be called an oblique cone since it's slanted. But remember, as long as you know what the height is, you would just do it just the same as you would if it was a right, like a straight up and down cone. So it's a cone, so we know the area of the base is going to be that of a circle. So let's start just like always. Volume is equal to 1/3 the area of the base times the height. This case, again, the base is a circle. It gives us a radius of 1.1, so it'd be pi times 1.1 squared. So in a calculator, I'm going to take 1.1 squared and then just leave it in terms of pi. So you get 1.21 pi, and then the height is 2.7. So putting it into our formula, we have 1/3. Again, we're just going to divide by 3 at the end, times the area of the base, which was 1.21 pi, times the height, which was 2.7. So again, I'm going to take 1.21 pi times 2.7, figure out what that answer is, and then divide by 3 to get about 3.4 cubic centimeters. Example number 2. The Pyramid of the Sun in Teotihuacan, Mexico is a regular square pyramid with height 63 meters and a volume of 970,725 cubic meters. Find the length of the base. So first notice that it is a square pyramid. So they give us the height and they give us the volume. So we're actually going to work backwards to find the length of one side of the square base. So again, just like always, we're going to start off with our formula. Volume is equal to 1/3 the area of the base times the height. So the volume was the 970,725. We have the 1/3. The base in this case is a square. So remember, to find the area of a square, you just take one of the sides and square it. So let's put s squared in place of the big B. And then we're going to multiply by the height, which was 63. So to simplify this, I would just take the 1/3 times the 63, which basically is the same thing as taking 63 divided by 3. So I'd have that 970,725 equals, again, 1/3 of 63 would be 21, s squared. So the first thing I would do is divide by 21. So I'd end up with s squared equals 46,225. And then all I'd have to do then is take the square root of both sides to find the measure of one of the sides of that square pyramid's base. So the square root of 46,225 is 215. So it would be the length of one side is 215 meters, since we were given the label cubic meters for the volume. So one side would be 215 meters. Example number 3, find the volume of the right cone. So remember, for volume, we're going to do V equals 1/3 the area of the base times the height. And since it's a cone, we have a circular base. So our B would be pi r squared. But notice we were not given the radius. We were given the height, so we have h, but we were not given the radius to be able to find the area of the base. But we do know that this is 70 degrees. So we have to go back to trigonometry. This is not a special right triangle. It's not like a 30, 60, 90 or 45, 45, 90. And so we're given the 70-degree angle. This would be opposite the 70-degree angle, the 25 centimeters. And we're looking for the adjacent side, which again would be like the radius of the circular base. So we have opposite and adjacent, so we're going to do the tangent of 70 degrees, it'd be like the TOA, equals 25, the opposite, over the adjacent, which again, our adjacent side is actually the radius. So this would be a two-step problem. We're going to multiply by r and then divide by tangent. So r would end up being 25 divided by the tangent of 70 degrees, which is about 9.1, and in this case would be centimeters. So when we go to find our base now, it would be pi times 9.1 squared, and let's just leave that in terms of pi. So that would be 9.1 squared is equal to 82.81, so 82.81 pi. That's what we're going to put in place of the big B, and again, the height is 25. So we're ready to find the volume now. You would take 1/3 times the area of the base, which was the 82.81 pi, times the height, which was 25. Again, I'm going to multiply these two together first and then take that answer and divide by 3 to get about 2,168.0, because I had to round up. This was actually like 2,167.96, so I just rounded up to 2,168.0, but I showed the 0 to show that that continues on. It's not exactly 2,168. So again, about 2,168.0 cubic centimeters. That's it for this section. Make sure you jot down anything you didn't understand that we can cover before we move on, and we'll see you then.